नहीं नहीं नहीं
क्या?
एक मिनट.
Good afternoon, class.
Let me start sending out this communication.
Yeah. Somebody's mic is on. Can you please switch off your mics? Huh? Adish, your mic is on. Nicole, your mic is on. Okay. Yeah. Good afternoon, class. Okay. Now, today we will see combinatorics and okay. Prerequisite is that everybody should know what is NCR, NPR. Okay, everybody know what is NCR?
Yes.
And NPR. Okay.
Yes.
At
No,
least
ma'am.
oh, beta. Then I afraid you are in a wrong class. You should attend AMC 8 lecture. Huh? Okay. This is for advanced students. Huh? Okay. If you don't know these, huh? Then please attend AMC 8 lecture. Huh? You
Okay,
should
ma'am.
know this basic. This is an advanced batch. Huh, beta? Huh? Okay. Huh.
Excuse
Yes.
me, ma'am.
Yes.
Yeah, there was a problem with my registration, so I've missed the first few sessions. Are they recorded, right? Do you know where I
They
can
are
like?
recorded. Yeah, but I'm just a teacher. They share the link with me. I think
Oh,
you will
okay,
have to contact the admin person. I
okay,
won't be able to help you with any admin this thing. Of
okay.
course, I can help you with any mathematical help if you can ask.
Yeah.
Huh? Okay. Yeah. Now, yeah. Okay. Now, see, so I assume you know basics of combi, then I'll directly go to the problems because there are very many good problems, okay? And basically, I have gone through AMC problems. They stick on simple counting techniques only followed, but problems are very good level, okay? But counting, there are no hi-fi counting techniques except once they have asked once or twice they have asked the recurrence relation, so that I'll take care next time. Yes, beta? Yes, anybody? Okay. Unlike in pre-RMO we have varieties of techniques in combi. Here, mainly problems are they are such that you can do case bash or brute force or simple techniques like pigeonhole. Okay, not very hi-fi techniques are required. Okay, so let us do the first question. Azhar and Carl play a game of tic-tac. Okay, tic-tac-toe. And Azhar is the first one who is playing. Okay, and he places an X in one of the boxes, and then Carl places O in the remaining boxes. Okay, one of the remaining boxes. The typical tic-tac-toe. After Azhar plays X in one of the boxes, so afterwards again Azhar will play. So this game will continue unless all the boxes are filled or there is some row or some column in which like either 3 rows like one of the rows is completed by same sign or one of the column is completed by same sign or 2 diagonals are completed by same sign. Okay, followed, this much is clear. Huh? So one of the player was in row, horizontal, vertical or diagonal, whichever comes first. In that case, the player wins the game. Like typical TikTok, everybody must be known. Now, suppose the player makes their moves at random. So we are assuming that players are not using any strategy. Okay, the players make their moves at random rather than trying to follow rational strategy. Okay, and that Carl wins the game when he places his third O. Okay, when he places his third O or third zero, that time Carl wins the game. How many ways can the board look after the game is over? Now, so I have 3 zeros and 3 x's, okay, followed. So this is one of the way the board can look. The game will end when Carl places third zero because that time Carl wins. Okay, followed. This much is clear. So there will be 3 zeros, 3x and 3m.
Shouldn't there be 4x?
Boxes. No, beta. First who is playing Azhar. Azhar will play first, then Carl will put a zero. Then Azhar will
Okay,
play
I got it.
another and Carl will, and when third pair is been kept, that time it will the game will end. Correct? Okay, is that clear? That time the game will end.
Yes, it's clear.
Followed.
It's
Huh? Now I'm not. See, what is the question asked? How many ways the board look after the game is over? So I'm not interested in finding the order in which he is putting his first zero and second zero and third zero. I'm just interested how the board will appear. Again, rotation and reflection are not considered here. Okay, followed. Plainly, I've taken this as a board and this is like topmost like that. Okay, rotations is same, nothing like that. Simple question this is. Okay, everybody is ready for the solution? Huh? Okay, now pay attention. Now here, suppose I first select one row, okay, one winning row. See, there are 8 winning rows for card. Okay, so suppose I select one of the winning row for card. Okay, followed. Then how many ways are there for Azhar? Okay, so first case is that it is a horizontal row. Winning row is horizontal. So second case is it is vertical and third case it is diagonal. So if I select one of the winning row from this for Carl, so then how many possibilities of putting this thing for Azhar? See, totally Azhar have 6 squares left. So out of 6 square, he has to select 3. So it is 6 choose 3, which is nothing but everybody know the formula. May I directly do it? Huh? That is 20 ways.
Yes,
Correct?
20.
But note that out of this 20 ways, suppose my Carl selects the first one. Suppose Carl selects this is Carl's selection. Then Azhar may select this or this. This is not possible, correct? Okay, followed because if Azhar would have selected this or this, Azhar would have won before Carl. Because Azhar is the one who is going to play first. Is that clear? Okay. So I need to can Azhar if Carl's winning line, if Carl's winning line is this, can Azhar would have select this as his winning line? Is it possible?
No.
It's not.
No, because they are overlapped. Everybody understood? So only possible winning lines for Carl are 2, correct? So there are 20 ways, but out of these 20 ways, 2 are winning lines. winning lines. Therefore, there are 20 minus 2 total 80 ways for Azhar. Correct? Followed? Is this much clear to everybody? Any doubt, anybody? Huh? So for case 1, Azhar has how many ways? Case 1, Azhar has 18 ways. Can you tell me how many ways he will have for case 2?
Still
The
18.
same,
Again,
the same as same, right?
correct, same, right? Okay. And for third case, how many winning lines Azhar will have?
20.
20. No. There will be no winning line. In third case, there will be no winning line.
I was telling the total number of
20
possibilities.
possibilities. Correct. So no winning line.
Wait, is it because
So-
they're overlapping either ways?
Yeah, they overlap either ways. Correct.
Oh, okay.
Therefore, possibilities will be for Azhar will be totally 20 possibilities. Therefore, the number of can I use symbol for number of? Huh? This is a symbol we use for number of. Okay, number of possible boards will be what? In first case, Carl has 3 possibility, Azhar has 18. Okay, so 3 into 18 plus 3. Second case, Carl has 3, Azhar has 18. And third case, Carl has 2 and Azhar has 20. So this will be 18 6 are 108 plus 40. 148 is the final answer. Is that clear to everybody?
I didn't understand the
doubt?
last possibility.
Yeah, I'll explain. Last possibility. See, suppose Azhar has played like this. Can Carl have any winning line among remaining? Remaining are these squares. Do we have any winning line among remaining?
No.
No. Correct. Okay. Similarly, for other diagonal also, we don't have any winning line. So now Azhar has how many possibilities? Now Azhar have out of this 6 squares, he have to select 3. So 20 possibilities, correct?
Yes.
Okay.
Yes.
So Carl has 2 possibilities and Azhar has 20 possibilities.
Okay.
Is this clear?
So,
Any doubt?
so the number you've multiplied it by is the number of ways Carl can win, right? Like 3 and 2 represent
Carl
the.
can't win. Yes, Carl cannot win. Because if Carl wins, then Azhar have no chance to win. Followed? Is that clear?
Yes. Yes.
Yes.
In the last case, ma'am, where you have diagonals, what happens if Azhar chooses 1, 2, and 3, ma'am, locations 1, 2, and 3 for the crosses?
एक second. Azhar chooses 1, 2, and 3 for the crosses. It's okay.
Ma'am, but then that means 5, 4, 5, 6, ma'am, don't they have to all be circles, ma'am?
No. They will be empty.
All right.
See,
Okay, ma'am.
all
Yes, yes,
the
ma'am.
things
I
will
understand.
not be covered.
Yes, ma'am. The game terminates after one person wins. Yes.
Game terminates after one person wins. Okay. So if you have XXX here and OO here, these will remain empty.
Yes.
Followed?
Yes, ma'am.
Understood? Is that clear?
Yes.
Okay. So this was a very, very tricky. I think this was last question, one of the last questions. Okay. Okay. Is that clear? May I go to the next question? No. Okay. How many ways? 15 letters. I unfortunately forgot the year for this. Okay, 15 letters arrangement of 5 A's, 5 B's, and 5 C's have no A's in first 5 letters, no B's in next 5, and no C's in last 5. Okay. Everybody understood the question? Okay. So what I have is, I have 15 letters. So I have 555. If I divide them in 555, first five, middle five, and last five. Okay. First five, middle five, and last five. Okay. Now here in first five, I have no A's. Here I have no B's and I have no C's. Okay. What do you mean by this? That means in first five, I have only B's and C's. Okay. Followed? Huh? And here I have only A and C, and here I have only A and B. Correct? This much is clear to everybody? Now here, let us assume, in first five, we have, suppose X number of B's in first five. Okay, X number of B's. So, what can we say? How many C's you will have here?
I can't see the board.
5
minus X.
Everybody else can see the board?
Yes.
Yes, ma'am.
Better than I suspect some internet problem at your end. Huh? Better. Okay. So 5 minus X number of C's. Correct? Followed? Now, so here what will be number of A's? Sorry, number of A's. First, let us decode number of C's. Now, note that C's are present only where? C's are present here and here, only here and here. And totally we have 5 number of C's, out of which 5 minus X C's I have taken here. So number of C's here would be how many? X C's, correct? So can you tell me how many number of A's will be here?
5 minus X.
5 minus X, correct? 5 minus X. So number of A's here will be
X.
because I have only X number of A's, correct? I have only 5 number of A's, correct? And I've used 5 minus X here. So here how many I'll get?
X.
Because A's are present only at these two places. So here X A's, and therefore number of B's will be how many? 5 minus X, correct? Followed? Is that clear to everybody? Should I explain once again? See, I don't have any C's in last, correct? No C's here. Followed? No C's here. No C's here. So I have C's only at these two places. If I consider 5 minus X C's here, naturally I should get X number of C's here. Now, totally we have 5 in the middle. So, number of A will be 5 minus X. Again, A's are present only here and here. So, remaining X A's should be present here. And I have 5 letters here. So, number of B's will be 5 minus X. Is that clear to everybody? Any doubt, anybody? So, how many ways are there of permuting X number of B and 5 minus X number of C's in first 5?
Five CX.
Then
5 choose X.
P5.
5 choose X, beta. Why? Because out of 5, or you can, out of 5 places, I have to select X places for my B. Or you can take it that permutation with repetition. So it is totally 5 objects, out of which X objects are identical, they are B's, and 5 minus X objects are identical, they are C's. Correct? Similarly, here also 5 choose X permutations, and here also Why choose X permutations, right? Any doubt, anybody? Okay. Therefore, number of arrangements um, of 15 letters will be how many? That will be summation over X of 5 choose X whole cube. Correct? Sorry, just.
Ma'am, so wouldn't you also multiply all three of these expressions together first?
Yes,
Yeah,
yes.
you've done.
That's why I'm saying 5 choose X whole cube. 5
Oh.
choose X into 5 choose X into 5 choose X. Huh? Okay, and this is summation over X. So what are possible values of X? What are possible values of X?
0 to 5.
0 to 5. Perfect. Okay. So I need to just calculate this, like 5 choose 0 whole cube plus 5 choose 1 whole cube till 5 choose 5 whole cube. Calculation part, is it okay if I leave? Huh? You will be comfortable doing it? Huh?
Yes.
We should do more problems. I think this is case bash. So is it okay if I leave it for homework? Huh?
What do
Third
you
problem
mean
is
by bash?
case bash means you have to take different cases. Okay.
Okay, ma'am.
I'll help you with the cases and then okay. Huh? You must not be knowing only the name case bash. Logic you must be knowing. Huh? Okay,
Yes, ma'am.
nothing.
Yes, ma'am. I'm familiar with casework.
Casework. Okay. So you want me to show this or should I go to, so I can do some good problems? Huh? Okay.
Yes.
So 3 problems I'm leaving for homework. 6th problem. Let us do 6th problem. The problem which has some nice thing to tell, that I will do. Okay.
Ma'am,
Because I have many problems. Yes, beta?
ma'am, could you scroll up so I could take a screenshot of the homework questions?
Beta, at the end we will take all screenshots together. That is okay?
Yes, ma'am.
After the lecture, I'll wait for all screenshots together. Okay, like yes. Now, regular polygon with 5, 6, and 7 and 8 sides are inscribed on in the same circle. Okay. So suppose I have a circle. This is a big fat circle. Sorry for that. Suppose I have a circle and we are inscribing a regular polygon of size 5, 6, and 8. Is it okay if I do the rough? Sorry. Is it okay if I do the rough drawing now quickly? So let me inscribe. Assume this is regular pentagon, and let me inscribe a hexagon. Okay, let me inscribe only pentagon and hexagon so that the figure won't be dirty and we will understand. This is a pentagon and this is a hexagon. Okay. I think I have, by mistake, I drew only
That was
pentagon. Yeah. I'm so sorry. I'm so sorry. Just give me a second. Oh. Just sorry for this. Something like that. Okay. So something like that. Now assume it is regular. I know it's not regular. But is it hexagon or? Oh.
It's a heptagon.
It's a, yeah. Sorry for that. extremely sorry for that. Hate wasting time. Just give me 2 seconds. Is this? Yeah. Okay. Now I will draw the figure later on and let you know. Huh? Now, something like this. Assume this is a regular hexagon. Now, main thing is here, consider any side of a pentagon. Tell me, it is cutting how many sides of the hexagon? Because they have said that there is no common point. Okay. No two polygons share a vertex. There is no common point. And no three of side intersect at the common point. So just let us first observe. See, always in mathematics, you have to divide and rule. First observe a pentagon and a hexagon. Okay, followed. And tell me that each side of a pentagon divides how many sides of a hexagon, intersect how many sides of a hexagon?
2.
2, correct? So
2.
each side of a pentagon will intersect 2 sides of the hexagon, right? Okay, is that clear? So number of intersections of hexagon and pentagon, okay, number of points of intersection between pentagon and hexagon will be how many? That will be 2 times the sides of the pentagon. Okay, that is 5. So I can say this is 2 times minimum of 5 and 6. That's the logic. Correct? Because each side of the smaller polygon will intersect 2 sides of the larger polygon. Is that clear? Huh?
How do you deduce
Yes,
that?
ma'am.
How do you reduce that physically, ma'am? Because if your figure isn't drawn perfectly, ma'am, then maybe that assumption might not be true.
No, that is logically. Okay, I'll explain. I'll explain. See, consider any side of the smaller polygon. Correct? Followed? Now,
Yes.
now, because the larger polygon have more vertices than the smaller polygon. Correct? Therefore, if I consider these arcs, okay, let us consider every arc. Okay, so in every arc, there is at least one vertex of the larger polygon.
Yes.
Correct? At least one vertex. One of the arc might contain 2 vertices. But in every arc, there is one vertex. From that vertex, 2 edges emerge. Right?
Yes.
So definitely my smaller polygon will divide, the side of this smaller polygon will intersect 2 edges, right? Of the larger polygon. Correct?
Yes.
Is that clear to everybody? Huh? Okay. Huh? Now, so see, you should not be dependent on the figure. You can take hint from the figure, but you should do the combinatorial argument. Therefore, the number of points of total number of points of intersection points will be equal to how much? Now, when pentagon and hexagon will intersect, you will get 2 times 5. When pentagon will intersect with septagon, again you will get 2 times 5. When pentagon will intersect with octagon, how many polygons are? 5, 6, 7, 8. Okay. Then again I'll get 2 times 5. When hexagon and septagon will intersect, you will get 2 times 6. when hexagon and octagon will intersect, you will get 2 times 6, and when septagon and octagon will intersect, you will get 2 times 7. Okay, is that clear? Followed? So you just have to calculate this. 2 times 5 is a 15 plus 12 plus 7 and calculate. Whatever is the answer. Is it okay if I leave the calculation? But everybody has understood the logic?
Yes, ma'am. Yes, ma'am.
Wonderful, wonderful. Now, okay, this reminds me one extra problem, which was not AMC problem, but the logic. Is it okay if I do that extra problem? Because they have asked this problem, so similar problem may be
Yes,
asked.
ma'am.
Now, suppose we have, yes, it just clicked to me to ask that problem right now. Okay, so this is an extra problem. Suppose we have some, say, 10 points, 10 points on this circle, P1, P2, P3, P4, P5, P6, P7, P8, P9, and P10. Okay, and I am drawing chords. Suppose the chords find the number of intersection of chords inside the circle. Maximum number of intersection of chords in the interior of the circle. Maximum number of points of intersections of chords of type, suppose Px, Py, I will say, where 1 less than or equal to x less than y is less than 10. Okay, everybody, is this clear to you?
Yes, ma'am.
Huh? Now let us consider, suppose I have 4 points. Okay, then how many chords will intersect inside and how many chords will intersect outside?
Only one will intersect inside.
Only one point of intersection inside. You are right. I should draw a better figure. Better I draw the figure like this. Suppose this is cyclic. Assume this is cyclic. On this smooth surface, drawing is difficult. So please assume this is cyclic. So you can see that only one intersection will be inside. Among all possible lines, okay, two pairs of chords if I take, okay, if I take AB and CD, they will intersect at P, and Q, only one ACBD will intersect inside. So that means I just have to select 4 points and that will give me only one intersection. Rest 2 intersections will go out of the circle. Is that clear to you? Okay. So the number of, and for maximum number of point of intersection, I assume that because I want maximum number of point of intersection, for maximum, clearly no 3 are concurrent. We can assume no 3 concurrent. Yes. No 3 concurrent. Therefore, the number of point of, somebody's mic is on, please.
Ma'am.
Just wait for 2 minutes. Let me complete this, then you ask me. So number of points of intersection will be how much? That will be simply 10 choose 4. Okay, is that clear? Any doubt, anybody? Any doubt, anybody? If I ask you number of chords, that will be how many?
10
22.
choose
10 choose. And if I ask number of triangles with vertices at these points, at pi or points of intersection?
C3.
Then choose 3.
Yeah. So that will be, suppose I call this number, the number of points of intersection, we call this number as k, then this will be k plus 10 choose 3. Okay? Followed? Huh? Understood? Is that clear? Huh? Any doubt, anybody? So if they ask any of this, you should be able to answer now. Huh? Okay? Any doubt, anybody? Yeah, somebody had doubt. Till then, I will show the next question also so that you can, yeah. Others try next question. What was doubt somebody was asking me? Mahajan. Somebody Mahajan has doubt? Shivam,
The lines drawn
yes.
as edges of a graph and the intersection as nodes, can we use the Euler equation?
Sorry, come again. Euler's, yeah. Okay. But better for Euler, yes. He's talking about E plus
V minus E plus F.
yeah, is equal to F plus V. I use these. You for F you use S or what? Surfaces. I use this for edges, okay, and this for faces, and this for vertices. Okay, But beta, how you will calculate surfaces? Calculating surfaces is a big task. We first calculate vertices so that we can calculate edges, and for calculating surfaces, we use the Euler's formula, beta. Followed? Understood? Is that clear? Because vertices can be calculated like this. 10 choose 4. Okay? It need not be difficult. But for surfaces, finding surfaces is very difficult task. Correct? Okay? For that, we use this Euler's formula. Beta? Okay? Any doubt, anybody?
Ma'am,
Shivansh.
To find the number of can we use the Euler formula?
For what?
If we had to find the number of faces.
Yeah. Then you have to use Euler's formula only. But I don't think they will give you such difficult problem. I don't think so. Okay. This is one notch above MC 12, I guess. Okay. Because I've never seen, I've seen only basic problems in here. Not very difficult. Only they are little tricky to calculate. That's all. Okay. Next.
ma'am,
Yes, beta.
ma'am, for the previous question, I'm a little confused with the derivation of the permutation.
Derivation of permutation is
Like the intersection of point.
yeah, beta. Let me explain you. See, we agree to that for every set of 4 points, for every quadrilateral, there will be only unique point of intersection. So out of 10 points, I will get 10 choose 4 quadrilateral. So there will be 10 choose 4 points of intersection. Is that clear?
Yes.
Now, number of chords here will be what? Simply 10 choose 2, correct?
Yes.
And number of triangles with points pi or point of intersection. So, there are 10 points and k points of intersection if I take, then k plus 10. Choose. For
Yes.
triangles, is that clear?
Yes, ma'am. Yes. Thank you.
Now, yes, going to next question. What is my next question? suppose S is a subset 1, 2, 3 up to 25, such that sum of any two not necessarily distinct elements of S is never an element of S. Not necessarily distinct means what? Not necessarily
The numbers could be
distinct
the same.
means yeah, means A plus A is also not allowed. 2A is also not allowed. Correct? Followed? Means if A and B belongs to S, okay, if A and B belongs to S, then A plus B is not allowed at all. Okay? Followed? A plus B is not allowed at all, but also A plus B is not allowed at all, but also but also 2A is also not allowed. Correct? Followed? 2A is also not allowed. Is that clear? Huh?
So the set doesn't have any even numbers basically.
Set doesn't have any even number basically. So what could be the maximum sum of maximum size of such set?
Ma'am, is it
Ma'am.
13?
13.
Perfect. Perfect.
How did we conclude that it can't have any even numbers?
Yeah. Because sum of any two not necessarily distinct elements. Okay. So
Yeah, so
A
if 5 is no, like if 5 is in the set, then 10 can't be in the set, but any other even number can be there.
No, two odd number make an even number.
I'm saying if A and B are in S, then only. Okay. I'm saying that if A and B are in S,
Yeah.
then that implies this. Oh, sorry. I wrote A plus. Sorry. Here yeah. I wanted to say A and B are in S, then A plus B cannot be in S, and 2A also cannot be in S. Followed? Is that clear?
Yeah, that's clear. That much is clear.
Followed? Now,
Yeah.
now all even numbers here, okay, till 24, okay, are double of some number in S only, correct?
Yeah.
So no even number will be in S, correct?
No, but S is
Followed?
yeah, but
Because 2 is what 2 ones are,
no, so-
4 is what 2 twos are.
no, we can just create says the set 2 and 6. That's a
Acha.
valid set.
Yeah. That is manageable. That is manageable. Correct. Okay. And 24 will be 2 12s. But of course, you can take S as simply 2 and 6. That is possible. But we want to take highest S. So most important candidate would be 1,
Yeah, all the odd numbers.
3, 5, all odd numbers. This is one of them, which gives me cardinality 13. Or I can take 25. No, so half means I can take S as 13, 14, 15, 16 till 25. Again, cardinality of S is 13. Okay.
Yes.
Follow.
Yeah.
Yes.
Is that
Although
clear?
wouldn't we still need to prove that no higher is possible?
Yes. In AMC you don't have to, but if this is a subjective problem, yes, you
Yeah.
need to prove that no higher is possible. And how will I prove that? Give me a second. Suppose S is a set with more than that, then give me a second. Is it okay if I give you another problem? till then, and so that will not waste time. You try this problem and give me a second. Is this problem visible to you?
Yes, ma'am.
Next problem. Give me a second. I will solve this. Okay. Okay. See what I can do. I have to create a okay. So let me take is this one? Oh yes, yes. See, pay attention. Let me take a set A, okay, as A1, A2, A sum n. Okay, A1, A2, N. Sum A1, A2, N. Okay. And let us take set B as B1, B2, B it will be n minus 1, no? Yeah, n minus 1, such that B1 is A2 minus A1. In general, BK is AK plus 1 minus A. For all K going from 1 to N, N minus. Okay, followed? So I'm taking difference between these two here. Okay. Now, suppose these are my good sets. Both are good sets. Followed? Then can any PI be equal? A is my good set. Sorry, A is my good set. Then can any PI be present in A?
No.
No, because if BK is what? A K plus 1 minus AK. So if AK plus 1 is equal to AK plus BK. So clearly BK cannot be in A. Correct? Followed?
Yeah, and then we can use a counting argument.
Yes. And we know cardinality of A is n and cardinality of B is n minus 1. Correct? So I need 2n minus 1 should be less than or equal to 25. Okay,
Yeah.
so n should be less than or equal to 30. Followed? Is that clear?
Yeah, that's clear.
Yeah, very good. Now, this is, I think, based on modular arithmetic, I guess.
Ma'am, is the answer 49?
Wait, sorry, I don't remember the answer. I can
I
solve it for you.
believe the answer is 40. Oh, wait, no, I solved it wrong. Give me a minute.
Okay, I can solve it for you. I don't remember the answer. Okay, let us call this set as A1, this as A2, so on till A100. Correct? They are sets of 10 elements. So A1, A2, A100. And I need to find out how many of this sets contain exactly 2 multiples of 7. So in 10 consecutive integers, how many multiples of 7 can be there?
1.
Or 2.
Or 2. Okay. For example, if I consider say 61, 62, 63, 64 and so on till 70. It has got 2. Correct? Okay. Followed. So each AI may have 1 or 2 multiples of 7. Correct? Now consider first 10 AI. Consider first 7 AI. Consider A1 union A2 till A10. Sorry, A7. Sorry, slip of tongue. A7. This is what? This is 1, 2, 3 up to 70. Correct? 1, 2, 3 up to 70. So it has got how many multiples of 7 it has got have? 10 multiples of 7.
Yes.
This contains.
Yes.
So I need to accommodate 10 multiples of 7 in 7 sets. And each can have one multiple of 7 or two multiples of 7. What is the conclusion? Some 3 of them should have double multiple of 7. Correct? Followed? So let us call the set with double multiple of 7 as good sets. Huh? So that it will be easier to write. So some 3 of these A1, A2 till A7 must be good set. That is sets with two multiples of 7. Correct? So that means in every slot of 7 sets, okay, 7 sets, we will have 3 good sets. Correct? Okay. In each slot of 7 sets, we'll have 3 good sets. Yes. Got it?
Hello, ma'am?
Yes. Yes.
Nothing, your mic cut out for 1 second, so I thought you were gone.
Sorry?
Your mic cut out for a second, so I thought you were gone.
Oh, no. Okay. So in each slot of 7 AIs, we have 3 good sets. Now we have 100 AIs, correct? So 100 is what? 98 plus 2, correct? 98 is a multiple of 7. So that is, I think, 7 into 14 plus 2, right? Okay.
Yes.
So in first 98 sets, we will have 14 into 3, that is 42 good sets.
Yes.
And now we need to check whether last 2 AIs are good set or not. So what is A100? A100 will be 991, 992 and so on till 1000. Okay. Now what is this?
We can
991 if I divide.
we can actually ignore this step because 42 is in the option and 43 and 44 are. And
Oh, wonderful. 43. I think there is a typo error. It was, I think, 43 because 2 of the options have typed 43. 42. Okay. I think this must be 43. But if it would have been 42, 43 was not there, 43, 44 was not there, you can ignore it. But if not, if 43 is there, then you check mod 7. 98 is divisible by 7. So 11. So this is 4 mod 7. Okay. So if I check 4 mod 7, then 4 plus 7, sorry, 4 mod 7, then 4, then.
Ma'am, what is mod 7 and that?
Beta, remainder when divided by 7. Mod 7 is remainder when divided by 7. See, if I get remainder of first number is 1, then see when an is good, if first number is 1 or 2 or 3 mod 7, correct? Why? Because if it is 1 mod 7, then I can add 7 number and you will get 8th number is again mod 7. Okay. If it is 2 mod 7, then also you will get. But if it is 4 mod 7, you will get only one number mod divisible by 7. Is that clear?
Yes, ma'am.
Only 994 is divisible.
Or even 0. Even 0, I guess. Sorry, my bad. 0. Okay. So, and A99, okay, if you take 981, 982 and so on, Okay, this will be 981 will give me remainder this minus 10. So that is minus 6. Means one more 7. Yeah, one more 7. This is okay. So this is a good set. So there will be 43 good sets. Got it? Huh? Followed? Huh?
Yes.
I must have made copy pasting mistakes from a book or somewhere where I copy pasted. Okay, it had got 42, 42, so I didn't check. Usually, I don't solve and keep. I don't have that.
Ma'am, A99 is not good because it has only one multiple.
No, it will have two multiples. 981 is good. Then 988 will be also a multiple of 7. Nee.
Ma'am,
81.
not a multiple, even ma'am. 980 is.
Oh, it is not a multiple of 7. Then first oh, my bad. 1 mod 7 will not help me. In that case, sorry, 981 is not a good, yeah. Sorry, I'm doing hurry. Sorry. Let us compute that see, initially, if it is,
Ma'am,
hmm,
ma'am, we can notice that for every 7 sets, the third, yeah, the third
2 minutes. Give me 2 minutes. Give me 2 minutes. If it is a 0 mod 7, yes, it will be a good set because I have 3 element. If first number is 0 mod 7, yeah, okay. Or it is a, yeah, 6 mod
6 and
7,
5.
5. Huh. Then it will be a good set. Correct? Okay.
Yes, ma'am.
Then it will be a good set. Because if it is a 6 mod 7, then next number will be 0 mod 7. And then after 7 numbers, I will have one number which is 6 mod 7 and again 0 mod 7. Correct?
Yes.
Here it will be 1 and 2, like that. If it is a 5 mod 7, 6, 0, then again I'll have 5 mod 7 and, sorry, wait, yeah, sorry, this was 601 and here it will be 560. Yes, 3 numbers will repeat, right? First 3 numbers will repeat, correct, at the end. Understood? Huh? Is that
Yes.
clear?
Yes.
Huh? Okay. So for 0 to repeat, the initial digit should be either 0 or second number should be 0 or third number should be 0. Correct? Okay. Followed. Either first number should be 0 or second number should be 0 or third number should be 0.
Yes.
Understood? Huh? Followed. Is this clear to everybody?
Ma'am, I have a doubt.
Ha, bolo.
Ma'am, so after we found out that we have 3 out of each, out of 7 sets that have good sets, so that are good sets, so can we use unitary method over there?
It's a unitary method only, beta.
Okay.
It's a unitary method only. Got it?
Yes,
Huh?
yes.
It's a unitary method only. Huh? Okay. Followed. Is that clear? Huh? Any doubt, anybody? Huh? Okay. So this is my first number and this is my 8th number, 9th number and 10th number. Okay. So either first number or second number or third number should be 0. Huh? Is that clear? Huh? Any doubt, anybody? Huh? Oh, sorry. Now, I think this is just easy counting problem. So may I give this for homework? Huh? Okay. 10th is also easy counting problem. 11th is a nice problem. Shall we do 11th problem? In a shooting match, 8 clay targets are arranged in two hanging columns of 3 hanging columns. Sorry, I think this is a typo error. It should be 3 hanging columns.
Ma'am, it's given
Okay.
in the next line.
Acha, it's given in next line. Three targets each and one. Acha, yeah. Sorry. Yeah. I think 2 hanging columns with 3 targets each and 1 column with 2 targets. Yeah. Sorry, my bad. They are not cumulatively saying. They are saying 2 hanging columns with 3 targets. 2 hanging columns with 3 targets and 1 column with 2 targets. Yes, correct. Okay. The marksman has to break all the targets according to following rules. Marksman first choose 1 column from which the target is to be broken, and he must break the lowest remaining target. Okay. So, for example, he can, suppose he chooses first, then he can break this first, then I will be left with like this. Correct? Then he selects this, then I'll be left with like this. Okay? Followed? Like that. Any order. But he can't break the upper target. He can't say I'll break this. That is not allowed. He has to either select this or this or this. Understood? Is that clear? Followed? How many different orders can 8 targets be broken?
Ma'am, isn't this just permutations with repetition?
Yes, it is permutations with repetition. Now, how? I will take this as ABC, PQ, and XYZ. Now, recollect that C should be before P and before A, and P should be always before Q, and Z should be always before Y and before X. Correct? So out of total 8 factorial permutations, okay?
Ma'am,
Out of total, yes.
Q should be before P, right?
Yeah, sorry, my bad. Q should be before. Just a minute. I think I'm writing it soon. Yeah. Let me write with this. Yeah. So suppose I label this ABC, PQ, and XYZ. Then C should be before B and A, and Q should be before P, and Z should be before Y and X. So total number of permutations are how many? Total number of permutations without any restriction. Is 8 factorial. Now, among all these 8 factorial permutations, okay, out of these 8 factorial permutations, if on ABC will have 3 factorial different orders, but we are allowing only 1 order of ABC, that is CB8. So I need to divide by 3 factorial, and among PQ, I need to divide by 2 factorial. Among XYZ, I need to divide by 3 factorial because I am allowing only one orders here. Is this clear to you? Any doubt? This was very old problem and very famous. Next is a very latest problem and nice problem. Okay. Suppose 13 cards are, oh, the figure is missing. A second. Did you read the problem till then? I'll find the figure. Yes. Just give me 2 seconds. Just a second.
Excuse me, ma'am.
Yes, beta.
Ma'am, actually, this is my first class, so I just wanted to know, like, what is the exact duration of each class?
It's just one.
Okay, thank you.
I teach for Olympiad. My basic Olympiad lecture is at least of 3 years. Yeah, but I think my 1 hour is about to end, or it is already ended. Okay. But because this is a batch of enthusiastic students, I tend to give little extra. Okay,
Ma'am,
so
is the ma'am? I think I have the answer. Can I say it?
yeah,
Ma'am, is the answer 12 plus 11C2 plus 10C3 and so on?
yes, I think that's correct. That's correct. That's correct. Huh? See, let me explain this problem. See, 13 cards are here. They are numbered 1 to 13 and arranged in a row. The task is to pick, like randomly arrange in a row. Task is to pick up the numerically increasing order, working repeatedly from left to right. Okay, for example, cards. Now, first you have to pick up the card number 1. Okay, huh? Numerically increasing order means obviously you have to pick up card number 1 first, then 2, so on till 30. So in first round, you will pick up 1, then 2 and 3. In second round, naturally you will pick up 4, then 5, and 6 is before 4, so we can't pick up it in first round. So 6 will be in third round, and 7 is before that, so you can't pick up 7 in third round. So you will go there in fourth round. You will go to 7 in fourth round. Okay, so fourth round you will pick up 7 and 8. Fourth round you will pick up 7 and 8 and 9 and 10. Then you will have to stop here. Now you have to pick up 11 in fifth round and 12 also and 13, and we are done. So here we pick this up in 3 rounds. Okay, they are calling the rounds as passes. Okay, now how many of 13 factorial possible ordering of cards will the 13 cards we pick up in exactly 2 passes? Okay, so clearly, suppose in first pass, I'm picking up numbers 1, 2, 3 up to k. Then in second pass, I have to pick up number k plus 1, k plus 2 till 13. Followed? Okay.
Yes.
So I have to place k plus 1 before k. Right? Okay. I have to place k plus 1 before k. So first what I'll do, I have to select some k places out of this 13. I have to select k places for my k cards. Okay. Followed? So suppose there are 13 places. So suppose I select some k places. Clearly, I will arrange in increase from left to right. I'll put 1, 2, 3 k. So arrangement will be only 1. Correct? And then I start from the beginning and start putting k plus 1 till 30. Is that clear?
Yes.
Huh? Is the idea clear to everybody? Any doubt, anybody? So number of ways will be just select some k places for my this, correct? But here hitch is that it might happen that I have selected first k then there is no place for k plus 1 at the beginning. One of the selection here is first k numbers. So that I don't want, because this is for as one of the selection could be first k places, correct? Followed. So that we don't want. Understood? So you have to simply take summation of these. Okay, 13 choose k minus 1. Okay, so total number of what you can say orderings will be summation over k. 13 choose k minus 1. Correct? Okay. Now, k should go from what? K can go from 1 to 12 only, because we want exactly 2 passes. Correct? Okay. Now, but note that 13 choose 0 is equal to 1, which is 13 choose 13. So for k is equal to 0 and k is equal to 1, the value of 13 choose k minus 1 is 0. Correct? Followed? Is that clear?
Yes, ma'am.
Okay. Therefore, I can extend this to k going from 0 to 13. 13 choose k minus 1. Correct? Can I write like this? What is advantage? Advantage is we know the first summation is 2 raised to 13. So it will be 2 raised to 13 minus 40. Correct? Followed? Any doubt, anybody?
Ma'am,
Okay. Yes, beta.
actually, this is like my first class attending so far. Do
Oh,
you
okay. Yeah.
do you know where do you like are there any resources that I can use to cover up what I've missed so far?
Yes. Yes. What I'll do, I'll talk to you. Along with that, I'll give them screenshot. Is that okay? To save time. Huh?
I think you have shared
Um,
some of them on the group.
is it okay if I call you later after class on your phone
Yeah.
number?
Yeah. No, I can help you right away. But if you want my contact number,
No,
I'll
I
give
have
you.
it. It's okay.
Yeah. See here, what you can do is, yeah, you can call me. What you can do is, I think somebody has created a group. I will share his number. Give me 2 minutes. I'll share his number. And on that group, I've shared all whatever resources I have. Okay.
Like for all of these resources, you can use for AMC.
I can't guarantee all of the resources.
No, I mean
Whatever
like
I have shared. Yeah. Okay. There might be, I think you Google search, you will get some more resources. Because, see, I frankly admit that I'm teaching for MC for first time. My main teaching level is for INMO and IMO. Okay. I'm expert in teaching for Indian Maths Olympiad. Okay. Pre-RMO, IOQM, all
yeah.
those exams. Okay. And especially for higher level. Okay. So this is the very first time I'm teaching here. Okay. So I hope everybody got all the screenshots. Huh? If anything is missed, you tell. So I may not be expert. I don't even get time to chalk out good problems for you, which I usually do for my students, because pre-RMO is after 2 weeks. So I set papers and everything. So I'm super busy in that. But I try to go through your past papers, and I have tried to analyze the papers, and whatever is most important, that I'm doing, because in 1 hour you can hardly do any miracle. Okay. But if you want extra help, I I can give you good problems of pre-RMO level, which somebody suggested other day, because pre-RMO problems are good and they are of the almost same level, little higher level also might be. Okay, so good pre-RMO problems I can provide.
No, the
Okay.
problems are not like what I'm looking for. I'm looking for like material to actually, learn the content. Because I'm kind of lost. I have not understood like how you're solving any of these any of these problems.
Okay. Material. I think there are many YouTube videos also. I think they were saying that AMC, you have many YouTube videos. Somebody was telling me.
Okay, I'll just join you. Just I'll just join that group and we can do this from there.
I don't think so. I can give any extra time
No, that's
to
fine.
you.
That's maybe like later on.
You can, because I'm not allowed.
Oh, okay.
I'm not allowed.
Okay.
I'm not allowed to even have WhatsApp relation with students. This just I'm doing out of the, to help the
Okay.
students. That's all. What I can do is, I can send you material, and after my pre-RMO, definitely if you have doubts or anything, I can help
Okay.
you with that. Okay.
Ma'am,
Whatever material I have shared. Can somebody tell me who has that? Who is the group owner? I forgot the name of the group owner and his contact number.
Ma'am, I'm
Yeah. Beta, what is your name and contact number? Can you please tell me? So I will.
Vedant, ma'am.
Yes, Vedant. Correct. Vedant. And your contact number?
99 9922 42 84 52.
Okay. Vedant, please check this number. So you can contact Vedant. He has a group and I've shared all material there. Okay. I can share my notes. If you go through my notes, which I have created for very basic level. If you go through my notes,
Okay, ma'am.
yeah, at least for modular arithmetic and all that. Yes, Beta.
Ma'am, but if somebody joins right now, they won't be able to see the previous conversation. So,
Yeah, we'll have to again
yeah.
share those notes.
Ma'am, could you
That's
type the
all.
number in the chat?
Sorry?
Could you type his number in the chat, Vedant's number?
Vedant, can you share your number of chat?
Ma'am?
Yeah, ma'am, just doing that.
Can you please scroll down to?
Yeah. Where, Beta? What you want?
Ma'am, would it be possible for me to have your mail ID or any way to reach you?
Yeah, I can give my contact number, but I check my WhatsApp. My name is Komal Ghadikaukar. But I check my WhatsApp only at night. Okay. So you can WhatsApp me and please don't call me, especially WhatsApp calling is big no, because my WhatsApp is attached to my laptop and then it creates problem during lecture. Oh, sorry. This is my contact number. First you take down my contact number. Okay. Take it down. I need to scroll down. Please take screenshot quickly.
Yes, ma'am.
Yes. Which problem somebody wanted? Which problem, Beta, you wanted?
Ma'am, I took a screenshot of it.
You took the screenshot. Everybody got every screenshot. If you want anything, you tell. I will share this document also, but unfortunately, there is no guarantee that shared documents are reaching to you. I have shared the worksheets also, but they are not reaching to you. That's why Vedant created the group. Okay, so may I stop here? Okay. You need anything, you can WhatsApp to me or, okay. As much as possible, I'll help.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am. Thank you, ma'am.
Thank you.
Thank you, ma'am.